In a previous video, I showed how to do division of polynomials using the old grade school method of long division. And this time we want to use a technique called synthetic division. And we should get the same result in the end, but it's a little bit different process, so I want to go over how it works. So one of the things that we do with synthetic division that's different from long division is we'll actually make a symbol that looks like this. It's kind of like a half of a rectangle there. And what we're supposed to do is put the coefficients of our original polynomial that's being divided inside that half box. So we'll put a 1 here for the x squared term, and a 5 here for the 5x term, and a 6 for the constant term. So if you're confused about where I'm getting those constants, 1, 5, and 6, it comes from the quadratic expression that's being divided. See, it is in the form of ax squared plus bx plus c, which is a quadratic expression. And the a is the number attached to the x squared term. So here it's clear that a is going to be a 1. Since there isn't anything there, it's assumed to be a 1. So we have 1x squared plus 5x plus 6 for our quadratic. Our a is 1, our b is 5, and our c is 6. So that's actually where I'm getting those values. And now we have to put something on the outside of our division symbol as well. So the types of problems that we're going to do with this are always going to be in the form of some polynomial being divided by an x minus a term. So we'll just have what's called a binomial of two terms. And for our particular problem, we have a polynomial being divided by x minus 1. So it's clear here that our little a is going to be a 1. Sometimes that gets a little confusing because you can see here that it's negative 1, but the actual value that's in the place of the little a is just a positive 1. So we've completed step 1, which is writing the coefficients of the numerator's terms according to descending power of x. So we've got the coefficient of the x squared first, then the coefficient of the x, and the coefficient of the constant. Our next step will be to place the value of a outside the division symbol. So I'm just going to actually rewrite the whole problem so that you can see it being done step by step. I'll put my coefficients back in, and now let's write the value of a on the outside, and our a is 1, so we just want to put that there. Now sometimes that can be a little confusing to people that the original binomial here had a negative on the 1, but here we don't have a negative. It's always going to be like the opposite sign of what you had originally, so that's something to watch for. Next, we're going to start the process of the division. So let me rewrite it one more time. And in order to start the process, you actually want to bring that first coefficient down and put it down below. Our next step will actually be to multiply this 1 here on the outside times the number that we brought down. I'll do that in the next line. Now when we multiply 1 times 1, we get 1. And we want to put the result of that underneath the next constant. So I'm going to put a 1 right there. We'll add the results, 5 plus 1. So 5 plus 1 will make 6. And then we want to yet again multiply the 1 on the outside times the result of our addition. So 1 times 6 makes 6. And the result that we get goes below the next constant. Add the results at the end. 6 plus 6 makes 12. And then we're actually done, and we just have to now interpret the results that we got. Hopefully you can see that there is a parallel between what we're doing here and the long division way of doing it. For example, here we added 5x plus 1x to make 6x, and you can see that we also have a 6 coefficient here. You can see here that we did 6 plus 6 to make 12 at the end, and that's what we have here as well. And so to interpret this final result, we want to let our first constant have a power of x that is 1x less than we started with. So we started with x squared. So this 1 is going to get attached to just regular old x. So it's going to be 1x. And then this 6 will not be attached to an x. It'll just be itself, plus 6. And our 12 is a remainder. And so that needs to be put over x minus 1. That's our final result. We can eliminate the 1 here to simplify if we want, and it's done. So our final result is x plus 6 plus 12 over x minus 1. Let's try another one with synthetic division. This one is 3x to the third minus 2x squared plus 3x minus 4 all over x minus 3. So it does fit that pattern of being divided by an x minus a. So we have a polynomial over x minus a. We want to figure out what that value of a is. We see that 3 is in the position of a. So therefore, little a is going to be 3 for our problem. Let's set up the synthetic division symbol. We'll put our constants in here in descending order. Negatives will be included as needed. And we just want to put a 3 on the outside because that's what little a is. All right, our first step, bring our leftmost coefficient of the polynomial down. And then we just want to multiply 3 times 3. So that's going to give us 9. And once we get that 9, we want to put it below the next coefficient. We'll sum that column, so negative 2 plus 9 actually makes 7. Okay, we want to multiply 3 times 7. It's going to give us 21. And so bring that 21 result up and put it right here. 3 plus 21 will make 24. We want to multiply 3 times 24, which is going to be 72. Put that 72 below the next constant, and we'll get 68. Now, if you recall from before, the 3 was attached to x cubed. Negative 2 was attached to x squared. 3 was attached to x, and then negative 4 wasn't attached to any variable. When we assign variables to our results, it has to be 1 power less than it was originally in that column. All right, so our final result here is going to be 3x squared for the first term. Then we'll have 7x, which is 1x less than we had originally. And then the 24 will actually just be a number, no variable attached. The 68, however, is our remainder, and that needs to be divided by the original thing that we were dividing by, which is x minus 3. So that's our result using synthetic division.